Hi everyone. In this lecture, we will be solving few problems on matrices and determinants. So here is the first question. We have to find the rank of the matrix. So in this case, highest possible rank is the least value of 3 and 4. Okay. So let's consider first 3 cross 3 minors. Okay, this column and this column. First 3 columns. I have taken first 3 columns. So let's find the determinant. So the determinant is 0. Let's check this column and this column. Okay, so 6 minus 14 plus 3, 0 minus 8, 16, so minus of minus 8 plus 8 and minus 24, 0. Okay. Now let us consider this column and this column. Okay, 2, 1, 3, 3, 4, 7, 1, 0, 1. Four minus 0, minus 1, 0 minus 4 and plus 3, 0 minus 4. Okay, I have done wrong. I have done mistake here. So minus 1, 3 minus 7. It is 8 plus 4 and minus 12. Again 0. So okay, now let's take this column and this column. Four, 2, 3, 6, 3, 7, 2, 1, 1. 3 minus 7 minus 2, 6 minus 14 plus 3, 6 minus 6. So minus 16 and minus 8 minus 2 plus 16 and this is 0. So this is again 0. So since all 3 cross 3 minors are 0, so rank cannot be 3. Okay, now let us try 2 cross 2 minors. Let us try this 4, 6, 2, 3. Let us try this, okay? Okay, this we can tell without lifting a pen. So 4 into 3 minus 6 into 2, that is 12. Okay. Now check this 2 cross 2 minor. So it is 8 minus 3, that is 5. Okay, we got 1 2 cross 2 minor. One square submatrix of A of order 2 whose determinant is not equal to 0. Stop right there. Answer is 2. Rank is 2. Now let's go to the next question. Okay, here you have to find whether this equation has no solution, one solution, non-zero unique solution or multiple solution. So let us solve this. So this will be 2x1 minus 2x2 is equal to 0, and second equation will be x1 minus x2 is equal to 0. So both equations are basically the same, which that is x1 is equal to x2, meaning this equation has infinite number of solutions, means multiple solutions. Alternatively, we know that we have ax is equal to lambda x. So this equation is of the form ax is equal to lambda x. So comparing, a is 2 minus 2, 1 minus 1, and x1 x2, and lambda x1 x2. So by comparing, we can say that lambda is equal to 0. Okay, so since lambda is equal to 0, that means the determinant is also 0. Because we know that product of eigenvalues is equal to determinant of A. So if determinant is 0, that means at least one eigenvalue is 0. So we can say lambda 0 into lambda 2 into lambda 3 is equal to 0. So since determinant is equal to 0, rank cannot be equal to 3. Rank cannot be equal to 2 in this case, since this is a 2 cross 2 matrix. So rank cannot be equal to 2, and this equation, this matrix cannot have unique solution. So we can use elimination method. So this equation cannot have, this is not true, and this is also not true. This is not true, this is also not true, and no solution, this is also not true, because x1 is equal to x2. There are multiple solutions, so we are left with only D, infinite number of solutions. Okay, let us go to the next question. Okay, consider a system of simultaneous equations This system has unique solution, infinite number of solutions, no solutions, or exactly 2 solutions. So to find rank, we need to convert matrix into echelon form. Okay. So let's rewrite this. The coefficient 2, 1, 2, 1, 1, 1. So we are writing augmented matrix. We are constructing augmented matrix. Okay. So now performing row operations. R2 changes to R2 minus 2R1 and R3 changes to R3 minus R1. It is 1, 2, 1, 6, 0, minus 3, 0, minus 6, 0, minus 1, 0 and minus 1. Now again R3 changes to R3 minus 1 by 3 R2. We will get 1, 2, 1, 6, 0, minus 3, 0, minus 6, 0, 0, 0, 1. So we have one complete row 0 in original matrix. So rank of the coefficient matrix means the original matrix is 2. Since rank of the matrix is the number of non-zero rows in its echelon form, so we have 2 number of non-zero rows in coefficient matrix or the original matrix. So rank of this matrix is 2 and rank of augmented matrix is 3. Okay, rank of the matrix is 2 and rank of augmented matrix is 3. Since rank of coefficient matrix is not equal to rank of augmented matrix, hence the system has no solution or system is inconsistent. Okay. So the answer will be C. This system has no solution. Okay, let us go to the next question. So notice that the second and the third columns of the coefficient matrix are linearly dependent. For how many values of alpha does this system of equations have infinite many solutions? So see, when two rows are same or when two rows or two columns are same or any relationship can be established, then determinant is 0. Here notice that the second and third columns of the coefficient matrix are linearly dependent. Yes, column 2, this column and this column. So you can write C3 as C2 times 4. Okay, minus 4. So we can say that obviously this coefficient matrix is going to have determinant as 0. So let's solve this through standard method. Let us construct augmented matrix. Two, 1, minus 4, 4, 3, minus 12, 1, 2, minus 8, alpha, 5 and 7. Now performing row operations. R2 changes to R2 minus 2R1. R3 changes to R3 minus half R1. Okay. New augmented matrix will be 2, 1, minus 4. Row 1 will remain unchanged. 0, 1, minus 4. Alpha, 5 minus 2 alpha. 0, 3 by 2, minus 6 and 7 minus alpha by 2. Okay, again after this R3 changes to R3 minus 3 by 2 R2. The new matrix will be 2, 1, minus 4, alpha, 0, 1, minus 4, 5 minus 2 alpha, and 0, 0, 0, 5 alpha minus 1 by 2. Now, for infinite solution, it is necessary that at least one row must be completely 0. So, these three entries are already 0. So, let's make this 0. So, 5 alpha minus 1 by 2 is 0. Alpha is equal to 1 by 5. So, we have alpha is equal to 1 by 5, for which this matrix has infinite many solutions. So, we have got only one value of alpha for which infinite solution exists. So, for how many values of alpha? So, answer will be 1. Clear? Let us solve the next question. Let ABCD be n cross n matrices, each with non-zero determinant. If ABCD is equal to I, identity matrix, then B inverse is. Okay. So let us write ABCD is equal to I. So we can rewrite this as, we can multiply D inverse both sides, both LHS and RHS. Okay. So this will be any matrix multiplied with identity matrix will result in the same matrix. So I can eliminate I from here. So this is A, B, C is equal to D inverse. Let us again multiply C inverse on both sides. So we have AB is equal to D inverse C inverse. Now we have to remove A. So let us multiply A inverse. Why we are multiplying A inverse to the left? See? Why? Because matrix multiplication is not commutative. That is, meaning A into B is not equal to B into A. So now we are left with B is equal to A inverse, D inverse and C inverse. So we have to find B inverse. Okay. So again taking inverse both sides, B inverse, A inverse, D inverse, C inverse, whole inverse. From property we can rewrite this as B inverse is equal to C inverse whole inverse, D inverse whole inverse and A inverse whole inverse, or C times D times A. So we have got the answer. This is the correct answer. Let us solve the next question. The matrix M has eigenvalues -3 and 5 and eigenvector corresponding to the eigenvalue 5 is one of the eigenvectors of the matrix M cube is. So from property we know that if lambda 1, lambda 2 and lambda 3 are the eigenvalues of matrix A, then lambda 1 raised to the power k, lambda 2 raised to the power k, lambda 3 raised to the power k will be the eigenvalues of A raised to the power k. Okay. So, but A and AK will have same eigenvector. Only eigenvalues changes, not the eigenvectors. Okay. So here you can directly answer this question as B. Also you can find the eigenvalues of M cube matrix since you have -3 and 5 as the eigenvalues. So for M cube you will have -3 raised to the power 3, -3 raised to the power 3 and 5 raised to the power 3. Okay. -27 and 125. So M cube has eigenvalues as -27, -27 and 125. Okay, but the eigenvector will be same corresponding to that vector, corresponding to that eigenvalue. Clear? Let us see this question. Which of the following is an eigenvector of the matrix? So first solve for eigenvalues by solving characteristic equation. A minus lambda I equal to 0. So we'll have 5 minus lambda 0 0 0 0 5 minus lambda 5 0 0 0 2 minus lambda 1 0 0 3 and 1 minus lambda. Okay, so we'll have 5 minus lambda, 5 minus lambda, and 2 minus lambda, 1 minus lambda, minus 3 is equal to 0. So solving 5 minus lambda square, lambda square minus 3 lambda minus 1 is equal to 0. So lambda will be either 5 or, solving this equation, you will get 3 plus minus root 13 by 2. Let us find eigenvector corresponding to lambda is equal to 5. Okay, let us put lambda in. We have to find Ax is equal to lambda x. Let us put lambda is equal to 5. Or we can directly put lambda here. Okay, put lambda here in the characteristic equation problem. So we'll get 5 minus 5 0, 0, 0, 0, 0, 5 minus 5 again 0, 5, 0, 0, 0, minus 3, 1, 0, 0, 3, and 1 minus lambda, 1 minus 5 minus 4. So x1, x2, x3, x4 equal to 0, 0, 0, 0. Now solve. We have 5 times x2, 5 times x3 is equal to 0. Second, minus 3x3 plus x4 is equal to 0, and 3x3 minus 4x4 is equal to 0. So since x3 is 0, x4 is also 0. So we got x3 as 0 and x4 as 0. And x1 and x2 may be anything. x1 and x2 may be anything. So eigenvector corresponding to lambda is equal to 5 may be written as k1, k2, 0, 0. Okay. So we have choice A. So choice A is the only matrix in this form with x3 and x4 0. Okay, so A is the answer. Let's solve the next question. For the matrix, the eigenvalue corresponding to the eigenvector is okay. So we have 4 minus lambda, 2, 4 minus lambda, and x1 and x2 are given. 101, 101 is equal to 0. Let us solve. So 4 minus lambda times 101 plus 2 times 101 is equal to 0. So 404 minus 101 lambda plus 202 is equal to 0. 101 lambda is equal to 606 and lambda is equal to 6. Okay. So answer is 6. Also, you may notice sum of entries in the row in all the rows is 6. See, 4 plus 2, 6, 2 plus 4 is 6. So if the sum is 6, one value of lambda must be 6. Let us see one more such case. Let's have one matrix as 1 minus 2 1 0 minus 1 1. So see, sum of row is 0, also 0, 0. So here in this case lambda is 0, and in this particular case determinant will also be 0, since product of eigenvalues is equal to the determinant of the matrix. Okay, let us solve next question. So for a given matrix, one of the eigenvalues is 3, the other 2 eigenvalues are. So we can solve this question by using property. We know that summation of eigenvalues is equal to trace of the matrix, meaning lambda 1 plus lambda 2 plus lambda 3 is equal to trace of matrix A, trace of this matrix. Okay, so we have one eigenvalue as 3. So 3 plus lambda 2 and lambda 3 are unknown. So will be equal to traces 2 plus minus 1 plus 0. So lambda plus lambda 3 will be equal to minus 1 minus 3 or minus 2. So see, you can eliminate choices. Here only choice B satisfies this condition. See, 3 minus 5 is equal to minus 2. So let us go to the next question. Let A be the 2 cross 2 matrix with elements. Then the eigenvalues of the matrix A raised to the power 19 are. So let us find the eigenvalues of this 2 cross 2 matrix from the characteristic polynomial. One, 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 minus 1. This is the matrix. Yes. Okay. 1 minus lambda, 1, 1 minus 1 minus lambda. This is the characteristic equation. 1 minus lambda minus of minus lambda n minus 1. Okay, equal to 0. So that is lambda square minus 2 is equal to 0. Lambda is equal to plus minus root 2. So eigenvalues are root 2 plus root 2 and minus root 2. Okay. Now we can use the property. Okay. So for a raised to the power 19, eigenvalue will be root 2 raised to the power 19 and minus root 2 raised to the power 19, or you can write this as eight 18 and root 2, also minus root 2, 18 and root 2 times root 2. So this will be 2 raised to power 18 into 1 by 2, 9 times root 2 and minus this is also 2 raised to the power 9 root 2. So answer will be 512 root 2 and minus 512 root 2. Okay. So answer is D. Let's see the next question. If X is an n-tuple non-zero vector, the n cross n matrix V is equal to X into X transpose. Tuple means rows. Okay. So X is 1 cross n matrix and X transpose will be n cross 1 matrix. Okay. We have to see X into X transpose. So X into X transpose is equal to 1 cross n, n cross 1. So we have 1 cross 1 matrix as the result. Okay. So we have 1 cross 1 matrix, that means rank is equal to either 0 or 1. Either 0 or 1. Okay. So since it is mentioned in the question that X and X transpose both are non-zero vectors. So neither of their ranks can be 0. So X into X transpose has rank 1. The answer is B. Okay, let's go to the next question. A is a square matrix which is neither symmetric nor skew symmetric. The sum and difference of these matrices are defined as respectively which of the following statements is true. So we have to find whether S and D are symmetric or skew symmetric. Okay, so S is plus A transpose. Let us find S transpose, which is A plus A transpose whole transpose. So A transpose plus A transpose of transpose. So according to the matrix addition, property of matrix addition, so we can write this. The S transpose is equal to A transpose plus A, which is equal to S. So that means matrix S is symmetric. Let us check D. A minus A transpose. D is equal to A minus A transpose. Let us find D transpose. Again A transpose minus of A transpose, which is equal to A transpose minus A. Let us check the matrix D. A minus A transpose. Okay, so D transpose is equal to minus D. Clear? Then so D is skew symmetric matrix. So S is symmetric and D is skew symmetric. So D is the correct answer. Okay, let's go to the next question. The number of linearly independent eigenvectors of is. Okay, let us write the characteristic equation first. Let us find eigenvalues from characteristic equation. 2 minus lambda 1 0, 2 minus lambda is equal to 0. So 2 minus lambda whole square is equal to 0. So we have repeated values of eigenvalues. So here there are possible infinite many eigenvectors here, but all are linearly dependent on each other. Hence, only one linear independent eigenvector is possible. So answer will be 1. Look, corresponding to n distinct eigenvalues, we get n distinct eigenvectors. Okay? Corresponding to n distinct eigenvalues, we get n linearly independent eigenvectors. But if 2 or more lambda value is equal, then only one linearly independent eigenvector is possible. Clear? Let's go to the next page. The eigenvalues of a 2 cross 2 matrix X are minus 2 and minus 3. The eigenvalues of the matrix X plus I and X plus 5I are. So X has eigenvalues minus 2 and minus 3. So with only this information, we can construct a diagonal matrix. Which has eigenvalues as minus 2 and minus 3. Since we don't have any additional information given, so we can construct a diagonal matrix like this way. Now x plus I, construct x plus I, minus 2 plus 1 minus 1, 0, 0, minus 3 plus 1 minus 2. Okay, this is multiplication here. X plus I times x plus 5i. So x plus I, we have constructed a matrix for x plus 5i, 3, 0, 0, 2. Okay, now multiply this x plus I, x plus 5i, minus 1, 0, 0, minus 2, 3, 0, 0, 2, minus 3 plus 0, minus 3, 0, 0, and 0, minus 4. So eigenvalues are clearly minus 3 and minus 4. Okay. So A is the answer. Let us see next problem. The eigenvectors of the matrix are written in the form, what is A plus B? Let us find eigenvalues from the eigenvalue problem. A minus lambda I, write the characteristic equation. 1 minus lambda, 2, 0, 2 minus lambda, x, putting the value of lambda is equal to 1, we'll have 0, 2, 0, 1, and replace x with 1 and A, 0, 0. Let us find A. So 0 plus 2A is equal to 0 and A is equal to 0. Again, putting the value of lambda is equal to 2 and x as 1b, so we'll get minus 1, 2, 0, 0, 1b is equal to 0. We'll have minus 1 plus 2b is equal to 0. Okay, so b is equal to 1 by 2. A is equal to 0, b is equal to 1 by 2. And we have to find A plus B. A plus B will be equal to 1 plus 1 by 2. A is 0, B is 1 by 2. So A plus B is equal to 1 by 2. So B is the answer. Okay, let us see the next question. X and Y are non-zero square matrices of size n cross n if x, y is equal to 0, matrix n cross n, then. So x into y is a null matrix. So we know that determinant of x into y is equal to determinant x, determinant y, or xy is equal to, okay. So if xy matrix is a null matrix, that means determinant of xy is equal to 0. Also, this is 0, that means either one of them are 0 or both are 0. See, x and y are non-zero square matrices. So, we are left with only choice C, where determinant x is equal to 0 and determinant y is equal to 0. Let us verify this. Let us construct one such matrix, x and y. Let's take x as 1, 2, 1, 2 non-zero square matrix and y as, okay, both are non-zero square matrices of size 2 cross 2. Now see, x, y is equal to 1, 2, 1, 2, 2 minus 1, 2 minus 1 is equal to 2 minus 2, 0, 2 minus 2, 0, 2 minus 2, 0, 2 minus 2 again 0. Okay. Now let's find x, 2 minus 2, 0 and y, which is again minus 2. Minus of minus 2 means plus 2 is equal to 0. Okay, verified. Answer is C. Okay, let's go to the next question. The two vectors and where A is equal to minus half plus j root 3 by 2 are. Okay, for two vectors to be orthogonal, their dot product should be 0. Okay, so if this is vector x and this is y, so x dot y should be equal to 0, or 1 dot 1 plus 1 dot a plus 1 dot a square should be equal to 0. Here a is equal to minus half plus j root 3 by 2. If you can recognize this, the cube root of unity values are 1 minus half plus j root 3 by 2 and minus half minus j root 3 by 2. The cube root of unity values are 1 minus half plus j root 3 by 2 minus half minus j root 3 by 2. So you can take this as omega, and if this is cube root of unity, then 1 plus omega square is equal to 0. It can be said that the cube root of unity is collinear. So according to the property of cube root of 1, the sum of its roots is 0. So this is 0. So we have answer orthogonal. So the two vectors are orthogonal. We have solved a sufficient number of questions for today. Please subscribe my YouTube channel for more such videos. You can find link of my Telegram channel in the description, where I have uploaded handwritten notes. Okay, let's wind up. and we will meet in the next lecture with few more questions. Till then, take care. Thank you.